Hello, I'm Jean-Nicolas, Head of IoT Solutions at InnovationLab. In the scope of our series of videos on organic electronics, I will highlight the complementary nature of organic and inorganic electronics and the main opportunities that we see for today and tomorrow in our field of organic and printed electronics. All of us live in an increasingly electronic world. Our daily lives, the economy, our health system and security rely heavily on electronic technology. As an example to illustrate how close to you this technology already is, as you watch this video, you may be using a display based on organic electronics without necessarily knowing it. The photons that reach your eyes and allow you to see me were most probably emitted by an organic material. Organic here is to be understood as mainly made of carbon, as opposed to inorganic, understood as mainly made of anything else but carbon. Silicon, for example. Indeed, organic molecules and materials are often used in combination with silicon materials to profit from the best of the two worlds. The future of this field is therefore one of an enhanced electronic landscape with new materials to make electronics more functional, more accessible and more sustainable. More functional because organic materials in the form of small molecules of polymers or other materials offer unique properties that are impossible to obtain with silicon alone, creating novel functionality for sensing, optics or energy harvesting. For example, organic materials are being developed for their flexibility, their stretchability and softness, properties typically not obtained by silicon or other inorganic materials. That is, one could imagine electronic devices that bend, that twist or conform to any surface. This is particularly important for the field of robotics, for example, where you want to have a soft interaction between a robot and an object. Other potential applications of organic electronics cover a broad range of fields, including medicine and biomedical research, environmental health, information and communication, as well as security. Organic materials promise more accessible electronic technologies through potentially lower costs, lower weight, and higher production throughput. They could also mean more sustainable electronic technologies, beginning with the use of materials that are synthesized or biosourced instead of being mined from the earth, and ending with potentially biodegradable or recyclable devices. However, currently, organic electronics represent only a small part of all the electronic devices that are available on the market. Arguably, the reason for this is the challenge to fabricate electronic structures at industry scale level with high yield and uniformity. This is where we at InnovationLab enter the game to bring these visions to reality through printed electronics, which makes organic electronics reliable. I'm working here at InnovationLab in the field of printed sensor to detect damage, temperature, pressure, approach or touch. If you have the need for detectors in such fields, feel free to contact us. We will find a solution based on printed and organic electronics.